Good afternoon, everyone. First of all, I would like to thank all the people here that helped to organize this wonderful event, and that is the Federation of Hong Kong Industries and also the Hong Kong Automation Technology Council. Thank you to all of you. I also would like to thank some of the other speakers. We have learned a lot today, also yesterday. And I would like to thank you for taking the time to join us at this forum. So I would like to give you a short overview of our company. My company is the GOM company. It is a German company, technology company. So we develop, produce and distribute software and hardware in industrial automated 3D scanning and also 3D testing using the latest technology in optical. Here is an overview of our 5 product lines: the Atos, the Tritop, the Aramis, Argus and Pontos. And today we are only focusing on the Atos system, which is a 3D scanning system. Our company is based in Braunschweig. It is near Hanover, near Wolfsburg. It is founded in 1990. It is today a private-owned company. Together with the other 8 daughter companies, we have about 490 people. Worldwide, we are working with other partners in 60 locations. And altogether, we form the GOM group with about 1,000 people. More particularly in China, we are working close to 20 years with a company called Protechnic, which is today here. And it happens that last week they were celebrating their 40th anniversary. So give them a big applause. Here is a short extract of our customer base. We are in many markets. Our strongest market is, of course, the automotive market and the suppliers, aerospace, turbine, consumer goods, and material testing. Altogether, worldwide, we have over 10,000 systems installed. Here is a quick overview of customer in the automotive business in China. So as you can see, we have both Chinese brands, but also foreign brands. Cars are everywhere in our daily life. Today, it is almost impossible to go out from your home and not see a car. So this is a picture that I took from my hotel in Hong Kong. I go out from my hotel, I can only see cars. The automotive industry worldwide last year has again made another high with 93 million passenger cars. And guess who is number 1? China again, with 28 million cars sold and produced in China. This is 30% of the total sales, 1/3. Just unbelievable. Having said that, the export of Chinese brand company in the other countries remains quite weak, with only 0.6%. And this is very weak compared to the Germany, to Japan, to US. A lot of study shows that Chinese brand car, they are okay in quality, but they are not what we are expecting from. Also the design. When you look at the car over here, it is okay, it is nice, but it is not comparable to the competitors. Also the technology inside is one step behind. And as you might all know, in China, our labor cost is keeping increasing. So today, China is at a pivot point. I think we need to improve our productivity and to combine automation and a lot of technology towards Industry 4.0 and keep our price competitive. Here is a definition of Industry 4.0, smart factory, Internet of Things. I think you had heard a lot today already and yesterday. I'm not going to read it, but here I have highlighted some keywords, and today we are going to talk about those keywords. Here I have 6 concepts where I will be explaining how the automotive market is going into that direction and how GOM is contributing towards smart factory. So first, we will talk about digitalization, the industry, the Internet of Things and data exchange. In order to reach smart factory, we have to digitize all the elements inside the production. We need to have all the element, all the real part will need a digital representation, a digital copy. And that will, with this, we can actually reach the Internet of Things, which is connecting all those elements together by Wi-Fi, by cloud, by internet. And those elements will collect and exchange data in real time between each other, both in the vertical direction, but also in horizontal. So we just talk about quality. In the factories, we have departments called quality management, QM, metrology room. So the metrology is the science of measurements. Today in our factories, there are 2 systems that is usually used. The first one has been introduced in the 1950s. We call them CMM, the machine code, coordinate measuring machines. Sorry. The problem with those machines is that they are very slow. Here is a short video, and you can see that those machines measure only at 1 point per second. It is a pretty slow process. Today we are going to talk more about 3D scanning, which is what our company is offering to the market. We call it the ATO system. The ATO system has been introduced since '95, and the speed we're talking about here is up to 16 million points per shot in 4 seconds flat. Here is a short video where you can see at the design department, we talk about having better looking car. Here you see designers taking a knife and shaping a clay model. So after shaping that, here is one of our scanners. In the middle you have a projector, and on the left and on the right you have 2 cameras. So in here you see projection of a certain pattern onto the clay model, and we record those patterns with the cameras. Looks a little bit fancy, right? So we are taking shots. So inside our software you see the wheel part that is digitized, and at the end you see the wheel part. So this is not the CAD model, this is the wheel part that has been fully digitized in our software. So the GOM system allows for the smart factories to digitize the wheel part into 3D data. So what do we digitize? We digitize point clouds. So point clouds means a lot of points, millions of points. And between those points, we are creating triangles, as you can see on the picture here. And by connecting all those triangles, it will give the overall shape of our 3D data. So this is about digitalization. So let's talk about, in a smart factory, on big data, and we will put in contrast to decentralized decision. So what means the big data in smart factory is that at the top floor, you have people that are able to monitor thousands of parts inside the factories. A car is having 1,000 of parts. You have so many cars into a production. So we are talking about maybe millions of parts. So those systems will be able to optimize the sequences. So we are here talking about optimizing the time to produce a car. At the top floor, it will be very easy to find the bottlenecks with all the software that we have. And it will be very easy to visualize and to analyze problems and take immediate actions. And of course, all those data will be accessible at all times and everywhere. So at GUM, we have just seen those 3D data. So this is an example of a backdoor, a sheet metal backdoor that we have just digitized. So this is the real part. This is our nominal model, the gap model. And with our technology, it is very easy to make analysis of the quality of the sheet metal part. So you see here a lot of color, but it is very easy to understand. The green color means that you have no deviation, so no error between your nominal data and your real part. The blue color means that you have a negative deviation, meaning that the real part is going inside towards the screen. And the yellow and the red color means that you have a positive deviation, meaning that your part is pointing towards you. So as you can see, with a CMM, you will need to read the report on the right side, and I think everybody agrees that it's very difficult. On the left side, it is very easy to make an analysis of the problem. Here is I have many examples, but here I just want to take one from the BMW factory, the mini car, when they have made a benchmark. And as you can see, CMM report is maybe 100 pages that can be only simplified with our technology with 2 pages. So the big data, with our 3D data, we are allowing the top floor to monitor the trend of the quality of our car. It is possible to optimize directly critical process and to make fast visual analysis of the problem. On the right side, you can find similar reports at Audi. Today they are using those reports and upload it to the Internet of Things. So this is at the top floor. So let's go down now at the shop floor, where those decisions can be made locally. So not all the thing has to be done on the top floor, but a lot of decision can be made on the shop floor. So no need of human intervention. And here I would like to show an example of what we call adaptive optimization, in real time by our machine using our 3D data. So with the color that you see, what we can do, for example, here I have an example of a CNC machine, a machining process where the part is machined. And afterwards, we are going to digitize the part and to make analysis of errors. And the colors that you have seen before are just sent back to the machine. And the CNC machine, with those information, they will do automatically optimization, compensation for the next part. Very nice application in the automotive industry. Let's talk about virtualization. So what means virtualization? Today in our automotive factories, the time between when you first design the car And when the car is ready to be commercialized, it takes a lot of time, months and months and months. So why does it take a lot of time? Because after the design, you will need to make a lot of simulation. You will need to make all the setup on the assembly line, and this takes a lot of time. As a matter of fact, in all the automotive factories, there are departments that exist, called the launch team, the pilot hall, the setup phase department. So those departments are spending a lot of time to set up all the machine. What kind of problem do you expect? Is that when you really are in the launch phase, you have a lot of unexpected behavior. Many things that we're doing in simulation were too simple. So when you go in reality, you are meeting even more problems. So there is a lot of tryout, a lot of optimization, and this costs a lot of money and a lot of time. Smart factory is a trend, as we know, but today there are a lot of developments towards using virtual reality, augmented reality, and also, more importantly, advanced simulation. So here I have a video at Mercedes-Benz where they are using advanced simulation to simulate how you are going to assemble parts in the car before we are launching production. So at the time when you are designing the car, you can already make all those simulation, all those virtualization up front, so that you are not losing time. So in here, that guy is going to see the sequence, which sequence he has to put which part. So in here, a lot of time, a lot of money are saved. Looks a little bit futurist, but it's actually happening. I'm not saying that all the factories has those technology, but we are at a very early stage. At GOM, we are also developing similar things in virtual assembly, but not like the video before. We are actually analyzing after everything is assembled, after all those sheet metal are assembled. And our software, we are making developments. We are trying to analyze the part when they are assembled, as I said, to make prediction if those sheet metal are penetrating to each other or if they have gaps already. So we are tracking the problems before all the parts are produced. Let's talk about automation that goes really hand in hand with Smart Factory Industry 4.0. We have seen our system before in manual mode. So when you are digitizing, an operator has to move the sensor in many positions and angle. 5 years ago, 10 years ago, between 5 and 10 years ago, at GOM we were doing already automation. The need for automation, I think, is clear to all of you. The use of robots minimize error from the operator. It enhances the higher throughput. More parts can be measured, more information can be gathered, and this with a higher process for safety. In here again, BMW Mini making benchmark on how much time they can save between manual mode or automation mode. So this is quite clear that it is time saving. The example that you have seen before at the design department, again here has been automized. Here are the setup that we have at Audi, virtualized, and also some very fancy installation. So not very usual. I think it's the only one installation where you can see robots that are put into the roof. Very, very special installation. So one thing that we have learned at GOM is that making those customized projects typically for us took in the past between 6 months and a year. So between when you have the idea, the design, and the implementation, it can take up to 1 year. So this is very, very long, and it was very hard for us at GOM to keep up with the demands. So 5 years ago, we have taken a decision to standardize automation. So instead of making customized projects, we at GOM provide a product, a standardized product. Today, it is called a scan box. So scan box is a box where I think the name is quite self-explanatory. Typically for scan box today, takes 3 days to 2 weeks depending on the box. So from 6 months to a few weeks, this is a big achievement for GOM. And I believe that for Industry 4.0, we have to take a little bit the same approach, where we have to more and more standardize everything so that we can accelerate the implementation of the smart factory. Here is the Scanbox families. We are able to provide automation solution for part from 1 millimeters up to 5 meters for car manufacturers. So very, very small part, as you can see, up to the roof, up to the side panel, to the body in white. In here, I would like to show you an automation cell that we have installed in Wolfsburg 3 years ago. So it is an automation cell at production line, inline we call it, for the Golf 5. So this is the 3D inspection of the 4-door of a car, the front and the back door. So as you can see on this line, you have one robot that do the pick and drop. It put it at that place, and then we have our scanner that will automatically scan the part. So after scanning the part, at the shop floor you are able to see the result. If this kind of process is stable or not, and if there is any problem, we can take immediate actions. All right. Let's talk about customization in the automotive. Today, when you buy a car, you can kind of customize the color of your car, the interior color of a car, and choose some of the options. But the smart factory can offer even more, and they will offer in the future endless possibilities to customize your car so that your car is a unique car. But having said that, a lot of technology, a lot of software needs to be developed. CRM system has to find a way to optimize the sequence of the whole supply chain. If you have one customization part and everybody has the same, we need to put a barcode on each part, and all the part has to be scanned and sequenced in the right order in order to achieve the just-in-time. In the customization, I think a lot of you have heard about 3D printing. So what is a 3D printer? The concept of 3D printers is easy, is to print what you want. Today, they can print plastic part, they can print metal part, and in the future, there will be new technology and new material. And what I see from China, we have also many good Chinese brand 3D printers that are on the market, that are quite good. Maybe in the near future, we will be able to print directly a car. When you think about it, 3D printers and a smart factory is kind of similar. You have the design, you give it to the smart factory or you give it to the 3D printer, and at the end, you receive your car. And I think that is the vision of a smart factory. At GUM, as you know, we provide 3D scanning solution, and with our scan box, the mantra is to scan what you want. So here is, you can see a simulation of our software where you put the part that you want to measure, and our program will automatically auto-teach himself to know how to scan the part. So this is what we have called the scan box. So it is basically a box. You open the box, you put the part that you want to digitize, you close the box, you press a button, and the part is scanned. Very easy. And last topic I would like to talk about is the collaborative robot. So it is the collaboration between human and robot. In here you see an example of, at Mercedes-Benz, where the robot is working together with a human. On the right side you can see that he's trying to assemble a motor. It is quite heavy. So in here they are using a small robot to help him to assemble the part, which is too heavy for the human. But working with robots, let's not forget about a tragedy 2 years ago in Germany when a young man of 22 years old was killed by a robot. It wasn't by a cobot, but it was during assembly. But the point I'm making is safety with robots is a serious topic, and I think we have to put a lot of effort here. So let's talk about the cobots. The cobots have two modes of operation. The first mode is mono to all of you. We are just using the industrial robot that we know, that are fast, that are strong, but a lot of sensors, a lot of vision system to detect if a human is in the neighborhood. All those safety devices has to be really well installed. So this is the first mode of operation. And the second mode of operation is probably what you know it more. It is a new kind of robots with not a lot of force, quite slow, but there is no safety device. And here I have a small video I can show you. The robot is moving, no safety device, the force is not so heavy, not very dangerous, but still a risk assessment needs to be done. So at GUM we are very active in following the trend of the cobots. We have in-house many robots from KUKA, from Fanuc. We are studying them, we are trying to use them. We have already since 2012 a student and researcher studying 3D scanning using robots. Also a bachelor thesis in 2015 studying repeatability, accuracy, force limit. Yeah, small bug. let's wait a little bit. So the topic of the cobots is very interesting for GOM. I think it will give a lot of new type of way to operate with the scanners, but also in other activities. So this is really not helping me. Almost there. Here we go. So as I said, I think cobots will bring a lot of new exciting solutions for the future. GOM is following the trend very carefully for many years already. But at this moment, we also try to integrate those technology with our solution, but we still need to wait a little bit the right time. At the moment, those technology needs to be more mature. We need some new norm and some new guidelines towards safety, as I said before. This is very important. I don't want you to be at the newspaper, as we have seen before. And the speed is also at the moment a small issue, and those robots at the moment is not so cost effective, but very promising technology. So in conclusion, we have seen 6 topics towards smart factories, Industry 4.0. Of course, GOM contribution is a very small and very tiny part. And I would like to end off my presentation by saying the 4th industrial revolution needs the contribution of each and every one of you today. Thank you very much.